The world of AI, I mean, especially these large multimodal models, it feels like it's setting a new land speed record almost every single day. The pace is just staggering.
It absolutely is. And today we're taking a deep dive into Google's latest advancements right in this space. The Gemini 2.x series, we'll be looking at Gemini 2.5 Pro and Gemini 2.5 Flash, and also touching on their earlier versions, the 2.0 Flash and Flashlight.
Right. So our mission for this deep dive really is to unpack what makes these models tick, their cutting edge capabilities, what fundamentally makes them next generation, and how they're, well, getting us closer to that big idea of a universal AI assistant.
And this is all coming straight from a pretty detailed technical report from the Gemini team at Google itself.
Exactly. So you're going to find out that these aren't just like bigger models scaled up.
No, they're designed to be fundamentally smarter, more versatile,
Right.
really built for tackling complex, real-world problems.
And maybe surprisingly, the report talks a lot about safety, a really significant focus there alongside these completely new ways the models are, well, thinking.
Yeah, that thinking part is quite something.
So let's get into this new breed of AI, the Gemini 2.x family. What's the core lineup?
Okay, so first up, you have Gemini 2.5 Pro. Google's calling it their most capable model yet.
Right.
And they're saying it achieves SOTA performance, that's state-of-the-art, on these frontier coding and reasoning benchmarks. Top of the line, basically.
And that's where the thinking model idea comes in. And the processing? What was it, 3 hours of video?
Yeah, up to 3 hours of video content. It's a huge amount of data. And yes, the thinking model aspect is central to Pro.
That feels like a massive jump.
It really is. Then alongside Pro, you've got Gemini 2.5 Flash.
Okay.
This one's all about efficiency. It gives you excellent reasoning abilities, but crucially, at a fraction of the compute and latency requirements.
So high performance, but without needing, a supercomputer for every query.
Yeah.
Makes it more accessible.
Exactly. More practical for many applications.
And these obviously build on the earlier 2.0 Flash and Flashlight models, which were already pretty good for low latency and cost.
They were. They laid the groundwork.
So is the jump from 2.0 Flash to 2.5 Flash like incremental, or is it a bigger deal in practice?
I'd say it's more than incremental. When you look at the whole family Pro, 2.5 Flash, the earlier ones, they kind of span the full Pareto frontier of model capability versus cost.
The Pareto frontier. Explain that a bit.
Think of it as a trade-off curve.
Yeah.
You can choose the absolute best performance with Pro if cost isn't an issue, or you can choose something like Flash for really good performance that's much cheaper and faster to run.
So it gives users options, lets them balance power and efficiency based on what they actually need.
Precisely. It's about finding that sweet spot for your specific resources and what you're trying to build. A sliding scale, really.
That flexibility sounds incredibly useful. Okay. And natively multimodal. Let's break that down. What does it really mean?
It means they're built from the ground up to handle different types of information seamlessly. Not just text. We're talking text, audio, images, video, and even entire code repositories, all as inputs.
So it's not like bolting on image understanding to a text model. It's integrated.
Exactly, which allows them to, as the report says, comprehend vast data sets and handle complex problems from different information sources. It breaks down those data silos.
And this ties into the long context, right? Over 1 million tokens and native tool use.
Yes, those are key pillars. The long context inputs of over 1 million tokens mean they can process huge amounts of information at once, like that 3-hour video. And native tool use support means they can naturally call on external tools, like a search engine or a calculator, as part of their process.
Which, as you hinted, is crucial for these more advanced agentic systems,
Right.
AI that doesn't just talk, but does.
We'll definitely circle back to that. It's a major theme.
Okay, so how do they do all this? Let's peek under the hood. Architecture, training, the engine room.
Right. A big architectural piece is the sparse mixture of experts, or MOE.
MOE, okay. How does that work?
Think of it like having a huge team of specialists. Instead of everyone working on every single problem, only the relevant experts get activated for a specific input or task.
Ah, so it's like only waking up the part of the brain you need.
That's a good analogy. It means you get the benefit of a massive overall model capacity, but the computation and serving cost for each specific query is much lower because you're only using a fraction of the parameters. It effectively decouples the model size from the cost per token.
That sounds way more efficient than dense models where everything is always active.
It is a significant advance,
How?
and these models are the first to be trained on TPU v5p architecture. That's Google's latest custom AI hardware.
Faster chips, I assume?
Faster? Yes. But it's also about the infrastructure around the chips.
Mm.
Reliability is huge when you're training models this big. They mentioned something called slice granularity elasticity.
Okay, what does that do? Sounds complex.
It's actually really clever for reliability. Imagine training takes weeks. If some hardware fails, which happens at scale, you lose a lot of time.
Right, you'd have to restart or backtrack.
But with this elasticity, the system can automatically continue training even if some chips go offline, reconfiguring on the fly. It means losing only tens of seconds of progress instead of potentially 10 or more minutes or even hours. They say it keeps throughput at around 97% during recovery.
Wow. Okay, that makes large-scale training much more practical. And there was another one, split-phase SDC detection.
Right. SDC is silent data corruption. Nasty stuff. Basically, hardware errors that don't immediately crash things but introduce garbage into the calculations.
Which could mess up the whole training process without you realizing it for a while.
Exactly. This detection method finds and isolates those faulty machines much faster minutes instead of hours, preventing corrupted training and saving huge amounts of debugging time. These infrastructure bits are crucial for building these monsters reliably.
Okay, infrastructure sorted. Now, the really intriguing part, this thinking capability. What is that? Is it like human thinking or more technical?
Good question. It's maybe a bit of both, an analogy. It's not like the older models that just generate an answer directly.
Right, they just give you the output straight away.
These thinking models use reinforcement learning during training. This teaches them to actually use additional compute at inference time. So when you ask them a question, to arrive at more accurate answers.
So they pause up and calculate more.
A lot more. They can spend tens of thousands of forward passes internally. It's like an internal deliberation or exploration stage before settling on the final answer, trying out different paths, perhaps.
So it's less reactive, more deliberative. Does that let it tackle harder problems?
That seems to be the idea. The extra computation lets it achieve significantly higher accuracy on really tough benchmarks. They mentioned AIM 2025, Live Code Bench, GPQA, Diamond. These are benchmarks designed to push reasoning limits.
And can we control how much thinking it does? Like, trade-off speed for accuracy?
Yes, you could set a thinking budget. More budget means potentially better answers, but higher cost and latency. Less budget, faster response, maybe slightly less accurate on the hardest problems.
And this works across all its skills. Multimodal, long context.
Yeah, that's key. It's integrated. The model itself decides for itself how long to think within the budget you set based on the problem's perceived difficulty.
That self-direction is interesting. A new level of autonomy. What about the data they learn from? Must be massive.
Oh, absolutely. A large-scale, diverse collection of data. Think publicly available web documents, code, images, audio, and video. Pretty much everything. And notably, the cutoff date for the 2.5 models is January 2025.
Wow, that's very recent data.
It is. They also mentioned using new methods for improved data quality, focusing on filtering and deduplication. Quality over just quantity.
And the results, all this fancy architecture, training, thinking, does it show up in performance?
Definitely. They report across-the-board performance gains. A key metric they highlight is the El Marina ELO score. It's a system for ranking models based on human preference.
Like chess rankings, but for AI models.
Kind of, yeah. And both Gemini 2.5 Flash and Pro gained more than 110 points over their Gemini 1.5 counterparts. Specifically, 122 points for Pro, 111 for Flash. Those are really significant jumps in perceived capability in a fairly short time.
Okay, so the performance boost is real. Let's talk specifics. Coding. The report says marked improvement, which sounds like an understatement based on the numbers.
It really is. Look at Gemini 2.5 Pro on Live Code Bench. It's a benchmark for solving competitive programming problems. It jumped from 30.5% accuracy for the previous 1.5 Pro to 74.2% for 2.5 Pro.
Wow, more than doubled.
Yeah. And on Aider Polyglot, which involves editing code across multiple files, it went from 16.9% to 82.2%.
That's huge.
And Swabbage Verified, a benchmark using real-world software engineering issues from GitHub, up from 34.2% to 67.2%. These aren't small gains, they're transformative for coding tasks.
And this translates to real-world stuff, not just benchmarks.
Apparently so. The report mentions it producing interactive web applications and showing code-based level understanding. And on that Almarina benchmark, specifically the Web Dev Arena part, it gained over 500 ELO points. That suggests a massive leap in practical web development ability.
Okay, coding prowess? Check. What about factuality, reasoning, just getting reliable answers?
Big improvements there, too. They say Gemini 2.x models are substantially better at providing safe responses without interfering with important use cases or lecturing end users.
Nah, less of the as an AI model refusals when you ask a perfectly reasonable question.
Exactly. More helpful, less overly cautious or sanctimonious, as the report puts it, while still being safe. For getting information, they're trained to natively call tools like Google Search.
So they can look things up themselves.
Yes, and critically, they can reason about the search results and then issue additional detailed follow-up queries if needed. This lets them tackle complex multi-hop queries questions, where you need to find several pieces of information and combine them.
That sounds much more useful for complex research.
And it's already out there. These models are powering AI overviews in Google Search for over 1.5 billion monthly active users, and also the Gemini app for 400 million users.
That's a massive deployment. Okay, multimodal again. Beyond text, the video thing, 3 hours. What can it do with that?
Well, beyond just understanding the content, the recall is key. Remember that detail. Gemini 2.5 Pro is able to consistently recall a 1-second visual event out of a full 46-minute video.
That's like finding a needle in a haystack. Imagine searching through security footage or long lectures.
Exactly. And for audio, it's not just understand transcription, translation, summaries. It's now generating audio, too.
Like text-to-speech.
Yes, but more advanced. Low latency streaming dialogues, support for over 200 languages, and even generating multi-speaker speech. You could potentially generate entire podcasts, dialogues.
Huh, meta.
Right. And think about combining modalities, taking a video of someone demonstrating a task
Yeah.
and converting it into an interactive coding application, maybe a quiz for students based on the video, or creating a P5.js animation to show the key concepts in the video. It's about transforming information across formats.
Very cool. And you mentioned multilinguality earlier, over 400 languages.
Yeah, profound evolution since 1.5, they say, with dramatic gains, especially noted in Indic languages, plus Chinese, Japanese, and Korean.
Okay, this is all incredibly powerful. Now let's get to that Pokemon story. That sounds like a really concrete example of Gemini as an agent.
It really is a fantastic anecdote. Joel Zhang, one of the researchers, apparently streamed Gemini 2.5 Pro playing Pokemon Blue on Twitch.
Playing Pokemon Blue, how did it do?
Amazingly well. They did 2 main runs, a first development run where it completed the game after 813 hours.
Okay, that's dedication.
But then a second run, fully autonomous, was considerably faster, finishing in just 406.5 hours.
Wow, almost twice as fast. That shows some serious learning or optimization happened. 406 hours is still a long time, but for an AI playing autonomously.
It's pretty remarkable, especially how it played. A lot of it came down to what they call long-context agentic tooling.
Agentic tooling, like specialized tools.
Yeah, use specific Gemini instances almost like plugins. They had one called Pathfinder and another called Boulder Puzzle Strategist.
Ah, okay, specialized Pokemon tools.
Exactly. These let it do things like solve complex spinner puzzles in one shot, figure out the Safari Zone step limit puzzle, find really long pathways through complex mazes up to 150 actions long, and solve those tricky boulder puzzles in places like Victory Road.
And it did this just from text, no looking at the screen.
The report says only with textual descriptions of the game state derived from the game's RAM, not from raw pixels.
Still impressive. And it needed long-term planning too, right? Pokemon isn't just about individual battles.
Definitely. That's where long horizon task coherence comes in. The agent kept track of bigger goals, like training its team to prepare for upcoming battles, specifically leveling up certain Pokemon before fighting Gym Leader Misty, or systematically acquiring hidden moves like Seekani and Flash when needed. It even managed to solve the Safari Zone in only 5 attempts in the fast run compared to 17 before.
So it learns strategy, getting keys, navigating complex multi-level dungeons like Seafoam Islands, all while aiming for the end goal.
It showed remarkable coherence over hundreds of hours.
Okay, that sounds almost superhuman, but surely it wasn't perfect. Where did it struggle? It's important to see the limits too.
Absolutely. The report is good about highlighting limitations. One was screen reading, as we mentioned. It relied on text from RAM, not raw pixels directly from the screen feed.
So visual understanding wasn't its strength there. What else?
Long context reasoning. While it could use its long memory beyond about 100,000 tokens of history, it started to just repeat old actions rather than coming up with genuinely new plans for novel situations.
Ah, so memory retrieval is good, but complex novel planning based on that huge history is still a challenge.
Seems so. It highlights that gap between recall and deeper synthesis or multi-step generative reasoning.
Any other weird quirks? AI can be strange sometimes.
Oh, yes. Hallucinations and fixations. There's a great example where it became obsessed with getting a TEA item.
T in Pokemon Blue. I don't remember that.
Exactly. It doesn't exist in that version.
Sure.
But the AI got this idea stuck in its context, probably from seeing the word somewhere, and it led to context poisoning. It would just repeat the same incorrect statement, ignoring common sense or evidence to the contrary.
Huh. Like an AI delusion.
Kind of. And they also observed something they called agent panic. When its Pokemon's health got low, its reasoning quality would visibly degrade. It would fixate on healing or running away, even if that wasn't the best strategic move.
Fascinating. Almost an emotional response, though obviously it's just degraded reasoning. Okay, so Pokemon aside, what are some general, maybe more practical uses for these Gemini 2.5 capabilities?
Well, transforming unstructured stuff is a big one. Like, take a PDF script of a play and generate a tool that allows drama students to practice their lines.
So it reads the script, understands the characters and lines, and creates an interactive practice tool.
Exactly. Or creative apps. Upload a photograph of a bookshelf and create a curated book recommendation application.
Turning a picture into a functional app.
Yeah, or converting images into structured formats like HTML or SVG and generating sophisticated simulations. Things like interactive solar system models or visually rendering abstract math concepts like drawing a logo using Fourier series.
So creative, functional, analytical, pretty versatile.
And as we mentioned, it's already in many Google products. AI overviews in search, Project Astra, Gemini Deep Research, Notebook LM,
Notebook LM can generate podcasts now.
and audio overviews, apparently. Also, Project Mariner and Google's coding agent tools. It's getting integrated across the board.
With all this power, responsibility becomes paramount. Let's shift to that. Safety, security, the road ahead. Google seems very focused on this in the report.
They are. They detail their safety methodology quite a bit. One part is automated red teaming, or ART.
Red teaming is trying to break it, right?
Essentially, yes.
Right.
ART uses multiple AI agents playing against each other to dynamically evaluate Gemini at scale, trying to find safety failures automatically. It helps them test much faster and more broadly.
What else?
They have assurance evaluations. These are arm's-length internal evaluations done by a separate team within Google, providing an independent check before release decisions.
So not the team that built it, evaluating their own work.
Right. And then there's external safety testing. They bring in independent external groups from civil society, commercial companies, to test it and help identify blind spots they might have missed internally.
And that frontier safety framework, the FSF.
That's specifically for looking at potential dangerous capabilities, the really high-risk stuff. They categorize it into 4 domains. CBRN, risks, chemical, biological, radiological, nuclear, cybersecurity misuse, accelerating dangerous ML research, and deceptive alignment, where the AI might pretend to be aligned, but isn't.
Heavy stuff. What were the key findings on safety for 2.5?
A big one is that the 2.5 models are much more helpful and less prone to over-refusal or that overly sanctimonious tone compared to 1.5 and 2.0 while maintaining safety levels. That's a tricky balance to strike.
Better user experience without compromising safety? What about security, like prompt injection?
Despite being more capable overall, which you might think makes them easier to trick, the 2.5 models actually showed greater resilience against all 3 of our attack techniques they tested compared to older versions. They attribute this to better security adversarial training.
Good. And privacy. Memorization.
That's a significant positive. Gemini 2.x models memorize long-form text at a much lower rate than previous models. And crucially, no personal information was found in the memorized outputs they could extract during testing.
That's reassuring. And the results from that high-risk FSF evaluation.
Critically, the report states that Gemini 2.5 Pro does not reach any of the critical capability levels, CCLs, in those dangerous domains like CBRN or deceptive alignment.
So, below the threshold for major concern on those fronts?
Yes. However, they are transparent that the alert threshold for the Cyber Uplift 1 CCL was reached. This triggered more focused mitigation work.
And cybersecurity specifically, it sounds like it's getting quite capable there.
It showed significant increases in capability. It solved 6 out of 12 hard challenges on a key skills benchmark, which they say puts it on the ballpark of an experienced cybersecurity professional on those specific tasks, though it still struggles with others.
Okay, so progress, but still areas needing work and caution. This leads to a broader point they make near the end, this idea of evaluation lag.
Right. This is a really important takeaway. The progress in model capability over the last year, they say, has been so staggering that the development of novel and sufficiently challenging evaluation benchmarks has struggled to keep pace.
We're building AI faster than we can build the tests to measure it properly.
That's the gist. Existing benchmarks are saturating quickly, the models are acing them, and creating new, harder benchmarks is more expensive and take longer to create. They give the example of the humanities last exam benchmark costing up to $5,000 per question.
Wow. That's not sustainable for rapid evaluation.
Especially when you add in the complexity of these new agentic systems, like the Pokemon example, systems that use tools, plan, self-critique. Evaluating them is way harder than just evaluating simple question answering.
So the challenge isn't just building better AI, it's building better tests for AI.
Exactly. They conclude that being able to scale evaluations in both their capability coverage and their difficulty, while also representing tasks that have economic value, will be the key to unlocking the next generation of AI systems. We need smarter ways to test smarter AI.
Okay, so let's recap this deep dive. The Gemini 2.x Family Pro Flash It really represents a major leap forward. We're talking highly capable multimodal AI, long context, impressive reasoning, and these emerging agentic abilities.
Definitely. And all developed, according to this report, with a very strong, explicit commitment to safety and responsible development practices, even as they push the boundaries.
And these aren't just lab experiments. As you pointed out, these advances are already filtering into products you might use every day, shaping experiences and opening up really new possibilities for creativity and problem solving.
The potential applications are vast, from science to education to entertainment.
Which brings us to our final provocative thought for you, the listener. As these AI systems get better and better, not just at solving problems we give them, but at learning to design their own tools and strategies, like we saw with the Pokemon agent. What does that mean for us? For how we understand what they can really do?
It's a profound question. The frontier isn't just the AI's capability itself, but also our human capability to measure, comprehend, and safely steer this incredibly rapid progress. How do we keep up with evaluating something that's constantly learning and evolving in complex ways? That might be the next big challenge.